Okay. Hello, testing 1 2 3. Oh, झाले सुरू. Set the timer. This stream will go on for an hour, and the plan is to test the contracts and this repo account abstraction, which has like ERC 4337 contracts. So let's see. Okay, let's start with cloning the repo to this. Yes, first step is, I hope you know that whatever it is, smart contracts or not. Okay, streams. I'm creating the streams repo, cd streams, then git clone, and this account abstraction. Let's okay, now open this streams account abstraction. Cool. Yes, I trust the author. Next step, you can't test this. I think commands are like npm install let's wait while it installs. What's the issue? Hard hat. I don't remember this. Okay, not really sure. Anyway, we don't really need this. We can create. This is in hard hat, and we are gonna change this to Foundry. Like Foundry, I'm more comfortable with. So let's create like a new folder. mkdir count abstraction Foundry, and just like open this. We can go here, and if you don't already know Foundry, like you can go to book.getfoundry.sh. Yes, and here everything is there, like first steps, how to create a new project. Everything is here. Let's create a new project with 4gnet. If this created the repo, now we just need to move /account abstraction /contracts root dot. Okay, so this will move the contracts folder to this project folder. Now you can see we have contracts, and we can just rename this. First, let's delete the source where all of our things, all of our contracts will stay, but let's delete rest of the related things that are generated as a boilerplate, and we are gonna rename this to source. Okay, cool. Now what's the plan? Yeah, we need to test it now. Not these tests. We need to test something else. Okay. Okay, let's first maybe tweet. We have started this, but let's fucking tweet about it. Hey, YouTube. ERC 4337, yes. Join the stream. Okay, let's, yep, let's live. Let's go to, yeah, my first step will be to create. I don't know. My plan was to test the cores. Interfaces, no need to do that. Legacy, I don't care about it. Samples, we can rewrite those. And tests, I also don't really care about these. Utils. Let's see where this is used. This is used in entry point, so we need to keep that. I don't want these because I'm gonna rewrite those. I don't want these also because why? Yeah, because those are test for samples, so we don't really care about those. Legacy, we also don't care about these. Delete it. New folder, samples, then new file, simple account .sol. Okay, let's see what are they using here. We need to install the dependencies also. suppose install @open zeppelin / contracts -- no commit. Okay, I don't know what was that, so let's just see what happens. Okay, now maybe I need to check this. Open the film. Contracts. Let's take a look at installation overview. Okay. This is wrong. No commit. Yes, let's see. Hopefully it should get resolved. If not, just like refresh this and yep. You just need to like save boundary.toml and then it should start again. Like the issue should be resolved. Let's see, there are no issues here. Interfaces, I don't think there will be any issues. No. Legacy, we don't really care. It's an empty folder, so we can remove that. Yes, let's start with this. SP, what was that? Compact definition. No. Yes. SVDX identifier. License identifier. Okay. Now that we have defined this MIT, let's go with 24. Keep it simple. Simple account. Simple account. Okay. Now we need to create a account contract first. Let's add a comment here. Read more about ERC4337 to understand read more about ERC4337 at EIP. Yes, here you can read more about this here, this EIP. Now base account EIP shows us the gives us the base account interface, so it should be somewhere here. I account. Yeah. So for any valid account contract, you need to follow this interface, but we are not gonna implement whole account contract with just interface. Instead, we are gonna import this from here. It has multiple things implemented, multiple requirements that are there. Like this is abstract contract, we are gonna inherit it and write some functions that are required, which are this validate signature, which we need to implement. We must implement, and yeah, only that one. That only, I think. Yeah. So let's start with first importing the base contract. Sorry, base account. Import base account dot slash core slash base account is base account. Was there error? Okay, let's see what else it needs. Yeah, we also need to implement the entry point, which returns entry point contract address. So let's take a look at this example. Yeah. So the contract we are writing is this account contract, and entry point is already here in our core 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 folder. Yeah, core directory, which is written by engineers maybe at Ethereum Foundation or at the ETH Infinitism org. We are gonna test it. We are not gonna rewrite this, but let's see. Just to give you a brief, like this is a contract that will not be implemented by us. It's already there, and we are just gonna use it. But when we inherit this base account, we need to return this address, like which entry point contract our account contract is using. So let's entry point private. We are gonna just store this. This is variable to store the entry point, and we can take it in like we can ask the user or deployer what is the entry point address. Sorry, we are not going to ask the entry point address. Instead, we are going to ask for argument which is of I entry point, which is of type I entry point. Let's give it a name, entry point. Okay, I entry point, and then we can set this entry point to underscore entry point. We also need to import I entry point from interfaces directory. Interfaces I entry point. Oh, Christoph. Yeah. Thanks, man, for joining. Uh, Pimlico like docs helped me a lot while writing the series, which is on my Medium. But yeah, thanks for dropping by, man. Yay. Yay. Our first viewer. Yes. Now let's tweet about it first. Yay. Yes. The first viewer, other than me and my brother. So let's see. Right. Yes. Stop. Damn. Yes. And a Pimlico. This is fucking phenomenal. Here's the stream. Let's see. The Pimlico docs help me a lot to understand the ERC 4337 for my Medium series, and it will also help me a lot in this streams to explain it to people. Yay! Let's drop the link for Pimlico. Docs dot. Sorry. Yeah, it's already a. Anyone who is interested in this, like anyone, check out docs. Okay, let's remove this. Yay! Yes. Okay, let's get back to the stream. Writing contracts. We are gonna import our entry point from dot slash interfaces slash our entry point. Okay. Yeah. Now that we have this, we need to implement the two functions that we talked about, which is this one. Let's copy this. affiliate return entry point. We have fulfilled the override. Mm, Already declared identifier. Let's remove this. Oh shit. We need to let's this is state variable. Let's name it s underscore entry point. S underscore entry point, and we need to put like override. Yes, so first is done. Now second one is underscore. No, yes, underscore validate signature. Validate signature. This. Let's solve first problem first, which is getting packed user operation from interfaces. So this is the packed user operation struct which we need for this. Packed user operation from interfaces slash packed user operation. Okay. Now we need to override this. Yes. Now let's understand what's going on in packed user operation. So in this example, this. So each user operation will have some data, which is here, which is this data, and sender address is the address of our account contract, and somewhere here like we need a validation that the owner of the account contract is the one who is calling the function, like not calling the function but sending the user out. So how we are gonna how can we test this, how can we check this is using the signature that is there, like ECDSA signature, like the regular signature we have EC recover, something like this, but we are not going to use this exact, but we are going to use something similar, which is in OpenZipLin, I think utils, cryptography, ECDSA. If we're gonna use ECDSA library from OpenZipLin to do that, instead of like directly calling the EC recover function, which is not very good, but let's see. What else is there? The signature. One more thing here. This signature. In this signature, we'll get the signed data from. Not signed data. In this signature field, we'll have the signature from the owner of the account contract, and we can like check the address if it's same, like after recovering. Like you can see, this recover function will return us an address which should be equal to the owner of the account contract. For this, we can like define address private owner, but better way to go about it is like we can just use OpenZeppelin for it. OpenZeppelin has access control, like access control ownable, and it should do like the trick. Let's start by importing it. Import ownable at the rate. Let's first check the remappings, like forge remapping. Yeah, so we need to use this. To go to account contracts folder, and contracts access ownable. So, contracts access ownable. Yes, we got this. Now this will inherit ownable too, and now we need to define the owner. Ownable message dot send. Not define. We need to pass the address of the owner to the constructor of ownable. Let me just open this again. Control F, constructor. Yeah, initial owner, whoever the owner is. Message.sender, we don't need it. Like, not every user is gonna deploy their own account contract, because that defeats the purpose of account abstraction. And then people can just use EOAs instead of account contracts. So let's assume the developer who is deploying the contract is gonna pass the address of the owner while deploying the contract. Let's address owner underscore owner. Let's follow the pattern, like the argument pattern. Owner, yes. Now the owner will be this, and whenever we want we want to check who is the owner, you can just there should be some function like owner function which will return the address. Now let's first understand. Let's try to go this is the blog I have written on this same thing. I may have used some different things, let me show you here. Simple account, constructor, address, entry point. Yeah, for ownable owner, I didn't use a ownable. Instead, I used an immutable variable. It's not an issue. Let's see. It won't be an issue. Same thing. And here is a validation function that I have written. Yeah, this is the validation function. It just takes user OP hash, which will be passed to this function via entry point. We don't really need to think about what entry point is right now, as we'll learn about it in the next stream maybe and see how it works. But it's just a gateway into account abstraction. Anyone can send a user operation to this function, and then not this function, to entry point, and then entry point will validate and execute that user operation. So right now we are just focused on user operation validation. uh, for how the whole thing works, please go through this blog maybe. I'll put the link for it. Just a second. Let me. Yeah, I'll just put it in here. Log contracts URL. Okay, this is public URL. You can check in the description. It should be there. It should explain you what we are doing here. No, not this. Where was I? Yeah. User OP hash is the hash of the packed user operation. This packed user operation without signature. You can get hash from entry point. So get user OP hash. Yes, you can see. For standardized purposes, just use this on any chain you're on. This will generate different hash, because it always generates different hash, but this encodes user OP hash, address of the entry point, and chain ID. So that's what I meant by that. Now let's go to our underscore validate signature. So you understood what user OP hash is, and user operation we already saw. Now this creates like a standard signature of EIP like 712, I think. Let me just go control 712. Yeah, it generates structured data hashing and signature. So yeah, you can see, you can read through this, like what it does and how it works, but it just creates a structure. It creates a structure for us. So bytes memory. Let me check code again. Sorry, bytes 32, not memory. Bytes 32 digest equal to, yeah, we need to import this first. This generates a digest which will like use to get the user operation, used to recover the address of the owner from the signature, which you can see here. Let's first import the message hash utils from OpenZeppelin. Where is it? OpenZeppelin cryptography. We need to check cryptography. Message hash utils. Okay. Utils / cryptography / message .sol. Okay. Dot to ETH signed message hash. and we'll pass the user OP hash to it. User OP hash. Okay, you can see here. Now we will recover who is the signer. Signer equal to ECDSA dot recover, and we'll pass digest, which is the data basically, and then user OP dot signature. User OP dot we haven't imported ECDSA. Let's go over this. ECDSA, where is it in the same? Yes, it is in the same CDSA. Okay, ECDSA. Now we need to understand what is validation data. So let's go to Control F, validation data. Yeah. So you can see in the account contract interfaces, it tells you what the account contract should do, which is must validate caller is trusted entry point, which is done by base account. Require, there should be a function. Yeah, this function. Let me just, yeah, this function checks the first part. Caller is trusted entry point. Trusted entry point is any entry point that we have defined in the account contract. Then it should validate the signature of user OP hash and should return validation sig validation failed on signature mismatch. Any other error must revert. Okay. We are not gonna care about this right now, as we are just learning. We can figure it out afterwards. So this, we'll check what is this. I know where it is. So it's an helper. Yeah, failed. Success. So whenever a signature validation is failed, you need to return this value, and if it is successful, we can return this value. Let's try to implement it. So how we're gonna check if it is successful or not is based on the address that we recovered. If that address is same as owner, then we are good to go. If not, it failed. So signer equal to owner. If yes, return this value, where helper, return sig validation confirm. Okay, else will return signature validation failed. Yeah, we need to first import. We also need to import this. Import validation failed. The validation successful from. Let's put this in correct way. Where is it? core/helpers. Okay. Now what's Okay, we can restrict this to view. Yes, now our validation function is done. Now next part. Let's go somewhere here. Yeah, you can see validation data. It tells you like what is validation data. Valid signature, we can return 0. We have seen that. Signature failure 1. And then this is something different, like we don't, it is not in the scope of this thing, like this stream. We are just going to see like how, yeah, we are not gonna check like ERC is 7766 right now. Instead, next thing is like the user operation is valid, user operation validation is done. Now we need to check like user operation execution. So this tells you like this method will be called by entry point and with current user operation instead of executing the call data itself. So yes, you might have seen our packed user operation has a call data, right? So if there is a call data, it will directly execute that call data. It will directly execute that call data on the contract itself. So calling like a raw call, it is gonna be a raw call data. That's something like address dot call. Then there will be a value here, and then call data. This is how you like call, execute the call data on that contract directly. We are going to construct the call data while sending it using our while sending the packed user operation to entry point. So we can define any function and construct the call data according to that. You might already know like how to construct the call data, like abi.encode with selector or signature, something like that, and then pass the arguments. We'll see that in tomorrow's stream. Like while testing this, we need to like create the whole thing, create the call data and actually execute it. So let's write a function called execute. It doesn't matter what you call it, because with abi.encode it just needs the function selector, not the whole function. Let me take a break. Yeah. So now we can write this. We need like a address, then address call. How did I construct this? Let me execute function. Yeah, like destination value and call data, as I shown you here. Like address call value, and then the data. Not exactly, I'm just showing you how it will be done. So address will be destination, then value will be UN256 value. This will be if we need to send some ether along with the call, and then the bytes call data. Let's call it data. External, and destination dot call data. Okay, value we can call like underscore value instead of value. Much simpler. What is this? Okay, we need to check now. This call returns like boolean and bytes. So boolean is like if the call is successful or not. If it is, we can do certain things. If not, we can do certain things, like we can put conditional over it. Bytes is just some data, like memory data. Let's say return data. We don't really care about this also, so we can just keep it. Is it this way? How do you? Okay, let me check here. Okay, I didn't do anything. Okay, so if the call is not successful, we need to throw an error. You did see, like in the example, there was an error that I defined, but here we are just gonna like if not success, revert. Sorry, yes, double C. If not success, revert, and we can just put it same thing. Put it as the same thing. Okay. So here now this is not very good. Like we need to specify what actually failed instead of just like throwing random unknown error. So we can define error here. Simple account underscore call field bytes. This is much more understandable. Like you can just say, you can give it any name, like XYZ or ABC, but it's not very clear. So simple account call failed, or yeah, simple account call failed is much clear. Like we are doing only one call here, and we are saying like simple account call failed, then return data. So it will tell you where the revert happened and what was the data, like return when the revert happened. So we are doing this, and with this we have done everything, almost everything. What is remaining? The thing that is remaining is execute. Like not everyone should be able to call execute. Instead, only the entry point should be able to call execute. So similar to how base account in valid user op. We are going to use this entry point function require from entry point, which will restrict the function call from entry point only and no one else. Like, you can put custom logic over there, but I'm just gonna keep it simple and going to use this function instead of putting some custom logic. External require entry point. Yes, now our function is done. Contract is done. Yes, let's hopefully it should be done. We'll know tomorrow if it's actually done, like after testing it. Yes, it's compiles successfully, so we can assume that there is no solidity error. At least, like, there can be a logical error. If there is, or if there is not, like, we can figure it out tomorrow. Let's see. So first part of this thing is done. We are going to write this, like, write the test unit test first, like testing individual contracts. Like, if the function actually executes this, like, recovery correctly and returns the data, and then we are going to create an integration test which will call entry point with packed user operation. That entry point will call our account contract. First it will call this, like, validate user of. If we return signature validation successful, then it will call the execute and we'll test, like, if that works or if it didn't. So let's see. Yeah, okay then. I think that's it for today, and I'll come back tomorrow to write tests. First unit test, then integration test. Okay, bye.